This tutorial will help you to complete the questions on homework number 4. So the first topic is vertex to standard form. It asks you to rewrite this quadratic function below in standard form. So let's take a look. So the first thing you need to understand is that exponents, right, that happens before multiplication and division. Right? Exponents happens before multiplication and division. So you can't just do this. I know you wish you could, but you can't. So we're going to get negative 2 times x minus 5 times x minus 5 plus 6. So now we've cleared our exponents, and now we can choose whether or not we want to distribute the 2. If you are, as soon as you hit the end of the parentheses, you stop. You don't keep going. You don't distribute it to both sets of parentheses. So if you'd like, you could distribute that negative 2 now, but the x minus 5 and the plus 6 stay the same. Now we're going to FOIL these two here. And when we do that, we're going to get negative 2x squared plus 10x plus 10x minus 50 plus 6. Combine your like terms, and we get negative 2x squared plus 20x minus 44. All right, let's put that in as our solution. Negative 2x squared, oops, type the 2 instead of a negative sign. Negative 2x squared plus 20x minus 44. Is that right? Negative 2x squared plus 20x minus 44. Okay. Yes. So that's how you expand it back to standard form. Right? The same thing will be asked here. In the front would be a negative 1, right? And you would get rid of your power of 2 first before you started distributing. So for this one, it would be y equals negative 1 times x plus 2 times another x plus 2 and then plus 1. So y equals negative x minus 2. Everybody else stays the same. Then I FOIL, get negative x squared minus 2x minus 2x minus 4 plus 1. Then simplify, negative x squared minus 4x minus 3. I forgot my y equals negative x squared minus 4x minus 3. All right, let's try the second lesson, standard form to vertex form. So it's asking you to complete the square, identify the equation you get, then tell me the actual coordinates of the vertex. So let's complete the square here. I'm going to use the same side method where I push the 11 over but keep everything on the same side. So I got to do half of this number and then square it. So that's going to be my magic number. That's how I'm going to complete the square. So negative 12 divided by 2 is negative 6. Negative 6 times negative 6 is 36. So I'm going to plus 36 and minus 36 so that I technically do nothing. This part I'm going to factor, and this part I'm going to combine like terms. So steal the sign from the middle, square root the last number, and then combine negative 36 plus 11. I believe that's negative 25, minus 25. All right, so there's our equation. X minus 6 in parentheses squared minus 25. So x minus 6 squared minus 25. Right, was that minus 25? Yeah. And then the vertex is the opposite of the inside number, so that's going to be plus 6, and the same as the outside number, and that's going to be minus 25. That's it. All right, let's take a look at the third one. Finding maximum and minimum values using technology. So that means you're going to need a graphing calculator. Turn on the y equals button. Let me make my screen large for you to see. And then we're going to type in this function, 2x squared plus 13.8x plus 19.7. Now I can move this over for you. All right, it wants us to find the minimum value to the nearest hundredth. So nobody wants to factor this sentence, that's for sure. And nobody wants to complete the square with this sentence. So that's why we're using technology. So I'm going to go ahead and take a look at this graph here and just see if I can even see the minimum. Yeah, I can. If it's not in your screen, then you need to change your window. But for us, it's fine. I can see it fine, so I don't need to change my window. But what I do need to do is calculate. So I'm going to press the blue button first, then the trace key, and I'm just going to select number 3, which is minimum. Make sure your cursor is to the left of that minimum point. Press enter. Make sure you move over to the right. Press enter. And then make sure that your minimum point, the vertex there, lies in between those 2 dotted lines. Press enter. And it said round to nearest hundredth. So remember, the minimum point is a y value, not an x value. So you're really only looking at this y number right over here. Right over here. This is the one you want to be looking at. So negative 4.11. Negative 4.11, I believe, would be the right answer. Negative 4.11 if rounded to nearest hundredth, right? Because the 1 is in the tenths place, the 0 is in the hundredths place, but the 5, which is in the thousandths place, is definitely large enough to round us up. Fantastic. So that's how you use technology to find a minimum or maximum value. Let's look at the 4th section, which is find the roots and the vertex of the quadratic on a calculator. Round all values to 3 decimal places. So that's the thousandths place. All right, here we go. Let's go back to our y equals button here. Let's clear out our old problem. And let's type in our new one. So I'll put this here so you can see. It's x squared minus 4x minus 117. X squared minus 4x minus 117. Now, that 117 is a pretty big number. I'm hoping I can see the vertex points, but let's just take a look at the graph. Ooh, no. I don't see very much at all. Right? I hate when that happens. So that's when I go back and I look at my equation and say, okay, look, it looks like the parabola is going to cross at negative 117. It's going to cross the y-axis, right? The y-axis at negative 117. So, and it's a positive parabola, so that means it's going to be shaped like a U like this. So here's what I'm going to do. I'm going to take my window, and I'm just going to go from negative 50 to positive 50. And because I know my y-intercept is 117, I think I'm going to change this to be negative 200. I'm not sure, but let's just take a look. Whoa. I think maybe I should have made this top part a little bit better, but it's not so bad. Okay, well, I can definitely see the minimum value now. And let's see, what does it say? Find the roots and the vertex. All right, so I'm going to go with the vertex first, and then I'm going to zoom back in and find these roots. All right, second, trace. Well, my vertex actually is a minimum, so I'm actually going to find the minimum value here. Ooh, that's pretty cool. I like where my cursor started. That's good. So press enter, arrow over 2 times, press enter. And it said round to the nearest 3 places. So that's 2.000. And this one doesn't need to be rounded. Negative 121. So let's see. 2.000. And this one was negative 121. All right, now it's time to find the roots. I'm actually going to zoom back in a little. I don't need to see all this business way down here anymore. I just want to concentrate on what's way up there. So I'm going to change my window from negative 200 to just negative 10 again. Let's see what I get. Okay, it's not bad. Let's see if we can't calculate these zeros. So second, trace, number 2. Now, I do not see my cursor anywhere because it's here. It's down at negative 117. So that means I got to arrow to the left because it needs to, oh, whoa, that was too far. So press enter. Now because my scale jumped so high, I pressed enter already. I pressed enter one time. I can't see it, but I'll just press enter again. See what I get. Ooh, my zero is -9, That is not bad at all. So it's -9. I think I have to round to, oh, if necessary. Oh, okay. Sorry, if necessary. So if it said round to nearest thousands, I have to put in the numbers. But if it says if necessary, then I don't have to. Okay, that's one root, -9. Now we got to find the other 0. The other 0, so second trace. What am I doing? Second trace, calc the 0. But this time I want to be way over on the other side. Again, I may have trouble seeing it. Oop, there it goes. All right, that's good. It's under, then over. I can't see it. It's way up there, but I know it's there, so I press enter. Woo, 13. That one was not so bad. Once I read that you have to round to 3 decimal places, I was expecting a hot mess. Okay. All right, let's submit it. Please be right. Yes. All right, so you might need to pause the video, go back and watch all the key buttons that I pressed and how to change your window and things like that. But I'm going to move on to the last one. Select an equation from the graph. I know you're like, what is this? Yeah, that is some business right there. All right, here's the fastest way to do this. Turn your calculator on, go into your y equals button, and type what you see. Parentheses, x plus 3, parentheses, then parentheses, oh, I'm not even in the y equals menu. Erg! I gotta do it all over again. X plus 3, parentheses, x squared minus 9. Oh, I need a parentheses up front here. So insert, second, delete, insert, parentheses. All right, let's take a look at this. Oh, I still got my wacky graph from last time. You see that? You see this really weird number line. So I'm just going to go back to the regular 10 by 10 window. The fastest way to do that without having to type all those numbers myself is just press zoom 6. Zoom 6 brings you back to the standard 10 by 10 window. Once you press that, voila, you get that beautiful, okay, that's not right. You see that? Right? It didn't even go above the x-axis, so I know that's not right. Okay, you can type the rest of these, but how would you do this if you didn't have a calculator? That's the question, right? So let me show you. Again, a calculator is the fastest way to do this, but if you wanted to know how you do it by hand, you think about what these factors mean, right? So if I have x plus 3 and I have x squared minus 9, I could actually factor this, because it's a difference of 2 squares, into x plus 3, x minus 3. And what that means is that each of these, separated unto themselves, even though we have a repeat here, would be the zeros, would be the roots, would be the solutions. So this one's going to cross the x-axis at -3 and +3. And remember we saw on that graph, let me show it to you again. Remember we saw on our graph here that it touched only in one place? That's because we have a repeat here. See, and it also touches at 1, 2, 3. So it would touch here and it would touch here, but it kind of went like that, right? Which is not what we're looking for. So this one was wrong. Now let's look at this one. This one says you're going to cross at the opposite of your factor, so that one definitely crosses at -3, but it's also going to cross at x plus 3, x minus 3. So it's also going to have another root at -3 and +3, so another repeat, and then one here. So that one's not going to work either, because we need one that goes through the 0. We need one that goes through 0. So let's take a look at this one. We have x, and then we have x plus 3, x minus 3. So this one has roots at 0, -3, and +3. So -3, 0, and +3. This is looking like it might be my winner. Let's double check this last one on the other side. Actually, let me undo that. Let me just bring all that up here. Okay, let's do this last one. X squared plus 9. Guess what? You can't factor that. It's not a difference of two squares. It's not a difference of two squares. So I think we found our winner. Winner. All right. So algebraically, I was able to prove that this had zeros at 0, -3, and +3, which is the same as this polynomial graph here. But when I type it into my graphing calculator here, when I type x parentheses x squared minus 9, and then I go to look at my graph, you see how the curves of the parabola are really extended. It doesn't look exactly like what I see on the screen. But I want to really, this is a very kind of a mean question. I want to point out to you that these are labeled and these are not. So I think they're specifically asking you this question where maybe this goes by tens. And they're not telling you that it goes by tens, but maybe it does go by tens. So this is another reason why not only do you need to know how to check it on a calculator, but you also have to have some sense about how is it supposed to look on the graph, because it doesn't look the same on your calculator because these are a different scale. They're definitely a different scale. So although this is the right answer, it doesn't look that way on your calculator. See, it shows you here the roots are 0, 3, and -3. So just be careful with this particular topic because this graph isn't scaled properly, meaning it is scaled properly, but its scale is not told. Scale is not told to you. So here's another example. All right, so I know we can use our calculator, but let's start thinking about this one again as what are the roots, not how high or low does the parabola go, right? Does this type, it's actually cubic, but it's not a parabola. This is a cubic function. But let's just take a look at it. All right, so for this one, the first choice here, x plus 5 and x squared minus 1, this is one of the factors, and this has to be split, since it's a difference of two squares, into these two items. So this is another factor, and this is the third factor. Remember, the factors are the opposite of your solutions, or your zeros. So we're looking for points at -5, -1, and +1. So -5, -1, and +1. So yes, this one is a match. This one is a match, and I bet if we put it in our calculator, it's going to look funky again because the scale is different. So let me just show it to you. Parentheses, x plus 5, parentheses, x squared minus 1. Let's look at that graph and see how it looks. Yeah, see, it goes way off the grid, and look, 1, 2, 3, 4, 5. So this scale is totally weird. This scale is 2.5, 2.5, 2.5, 2.5. But the answer is the first choice. And I proved that by finding the zeros algebraically. Very good. All right, that concludes our lesson for homework number 4.